Hello, students. This first lesson is on average rate of change, and it should be a familiar concept for you because it takes your knowledge of slope, secant lines, and graphs, puts it all together to talk about this concept of average rate of change. To start, let's review slope. If you remember, slope is a number that describes both direction and steepness of a line. So when we look at any type of line, right, we could draw it in a graph and we could determine a number that describes the steepness. We could determine if the slope is positive, if it's negative, if it's zero, or if it's undefined. You guys probably remember this as we said, slope is your rate of change. It is a rate of change, and it is basically the change in y over the change in x. And we always describe that as y2 minus y1 over x2 minus x1. Now, this is the easiest formula to use to figure that out. So let's use it to find the next couple of examples. So find the slope of the line through the points -1, 3 and 2, -1. So if we look, the slope, it doesn't matter which one you let x1 and y1 be, or x2 and y2. All right, what I like to do is just go from left to right. So I'm going to do 3 minus -1 over. If I start here, I must start with this x value when I subtract. So I'm going to do over -1 minus 2. Now, anytime we subtract the negative, it becomes what? Positive. So it's going to be positive 4 over -3. And we would simplify that as -4/3. Okay. The second one. Find the slope of the line that passes through the points -1, 3, and 5, 8. So right away, slope. We're going to go 3 minus 8 over -1 minus 5. That here is going to give us -5 over -6. But you got to remember, fraction is just a division problem. So negative divided by negative is going to simplify to a positive 5/6. Okay? So now, what is this concept of average rate of change? The first thing we have to know is what a secant line is. A secant line is a line that passes through 2 points of a curve. Okay? So if I draw some graph in the coordinate plane, such as this parabola. If I go ahead and draw a line, right, and this line goes through this graph at 2 points, that's considered a secant line. Okay, so now, what is the average rate of change? The average rate of change of a function describes the average rate at which one quantity is changing with respect to something else changing. Now, if you remember, if we look up here, these are the slopes of lines, right? So that slope is going to be constant throughout the line. But whenever you have a graph like this, if I plot any 2 points on the graph and I connect them, that slope is probably going to be different throughout different parts of the graph. Okay? So, if that's the case, what ends up happening is if A and B, all right, where A is not equal to B, are in the domain of a function, y equals f of x, the average rate of change from A to B is defined as, it's still the change in y over the change in x. But what we have to do is actually evaluate the function at those values. Okay? And then we divide it by B minus A. And if you look in this example here, you have this curve and you have this secant line in the graph. Okay, if we find the 2 points that this secant line goes through, we're going to use those 2 points to find the rate of change. Okay, let's take look at a couple of examples. So now in example 1 here, right, suppose that g of x is equal to 3x squared minus 2x plus 3. Find the average rate of change of the function from -2 to 1. So that means we have x is -2 and we have x is 1. So if we were to graph this, we would look for these 2 points. But we actually have to right now evaluate g of x. Okay, And the first point we're going to evaluate it at is g of -2. So I take everywhere I see in the function -2, I'm going to substitute it in. 3 times -2 all squared minus 2 times -2 plus 3. And if I evaluate this, that's 3 times 4. That's going to be plus 4 plus 3, which gives me 12 plus 4 plus 3, which is 19. Okay, so g of -2 is 19. Now we have to find g of 1. So g of 1, same thing, everywhere I see an x, I'm going to plug a 1 in for it. And now, what's 3 times 1 is 3. That's going to be minus 2 plus 3. That's going to give me 1 plus 3 is 4. So now I can go ahead, and what I'm going to do is I'm basically, when I talk about this rate of change, average rate of change, I'm basically doing g of -2 minus g of 1 all over -2 minus 1. What did we get when we evaluated g of -2? We got 19 minus, what did we get when we evaluated g of 1? We got 4 over -2 minus 1, and that will give me 15 over -3, and the average rate of change here is -5. Okay, and we're going to talk in a minute about easier ways to evaluate this function quickly. All right, but what I do want to do is move on real quickly down here. So, in example 2, the graph of the temperatures functions f during a particular day is given below. The temperature at x hours after midnight is f of x. So they're telling you the function is f of x. What is the average rate of change of the temperatures from 4 a.m. to noon, and then from 3 p.m. to 8 p.m. So what I have to do is I have to figure out f of 4 a.m. and then f of noon. Okay? So f of 4, if I go to 4 on the x-axis, I'm looking at this point right here. What is the y value? That is 40 degrees. Then f of noon, right, if I go up here, that's 12. That puts me at 58 degrees. Now I can go ahead and evaluate the average rate of change. The average rate of change is 58 minus 40 over 12 minus 4. What does that give me? 18 over 12 minus 4 is 8, which would simplify to, what is that going to be? 9 over 4, which is 2.25 degrees per, right, hour. Oh, jumped on me, per hour. And remember, this here is your degrees, this here is your hours, and that's why it's 2.25 degrees per hour. For the next one, 3 p.m. to 8 p.m. At 3 p.m., right, 3 p.m. is 1, 2, 3. I'm going to scroll up here. So f of 3 p.m. is 68 degrees, and then f of 8 p.m. All right, so we got to count 1, 2, 3, 4, 5, 6, 7, 8 p.m. would be 20 hours, right? And I'm going to put that, it's between 52 and 53. I'm just going to make it 53 to make it easy, right? So now, once I have these, now I can see the average rate of change is going to be 68 minus 53 over 3 minus 8, which gives me, what is that, 15 over -5, which is -3. So this means it basically goes down 3 degrees per hour. And if you look, the secant line through the first one, if I look at it, doesn't that line have a positive slope? So yeah, that's going to be a positive average rate of change. Here, this has a negative slope. It's going to have a negative slope. Example 3. When a rock is dropped from a high place, the distance the rock travels is given by the function d of t equals 16t squared, with d of t measured in feet and time t measured in seconds. The following table shows the distance the rock has fallen. Remember, this is your t value, this is the value of your function. So what is d of 1? So here we want to find the average speed of the rock from t equals 1 to 4. So d of 1 is 16, and then d of 4 is 256. So now we can go ahead and find the average rate of change. All right, in this case, we would do 256 minus 16 over 4 minus 1. That's going to give us, what is that, 240 divided by 3, which is 80. And since our numerator is the feet, we're going to say 80 feet per. Since our denominator here represents time, we're going to say 80 feet per second. Okay. Letter B, find the average speed of the falling rock from 2 to 4.5. So again, d of 2, let's do it in a different color. D of 2 is equal to, that's going to be 64. D of 4.5, right, is 324. So our average rate of change here is going to be 324 minus 64 over 4.5 minus 2. So right away, 324 minus 64 is 260 over 2.5, and 260 divided by 2.5 will give you 104 feet per second. Okay, so again, we've used a table, we've used a graph, and we've used a function. All right, now here's the thing. So for this last problem, right, it says a small manufacturing company makes specialty office desks. The cost in thousands of dollars of producing X desk is given by the function right here. Okay, it says find the average rate of change of the cost from 0 to 10 desks, from 10 to 30, from 30 to 50. So the first thing we have to do is we have to evaluate C of 10, then we have to evaluate C of 0. All right, sorry, could have done that in a different order. Here I have to evaluate C of 10, and then I have to evaluate C of 30. Then down here I still need to find C of 30, and then I have to find C of 50. And then I have to calculate the average rate of change. So here's the thing. To evaluate this function, what I would do is I would take the calculator out. Okay, and what I'm going to do is I'm going to go to y equals, and I'm going to type in that function, 0.0009 x to the third, right? And then I'm going to arrow out, and then minus 0.06 x squared, right, plus 1.6 x plus 5. The reason I put it in here, so I go to y equals, I type my function in. Now I could graph this, but the graph is going to look really weird and probably not make sense to you guys right now, right? But what I do is I use the table. All right, so I see right away, if I see right away, C of 0 is going to be just 5 right away, okay? When I go back, C of 10 is 15.9. So I know it's 15.9 here. Then C of 30 right away. If I scroll down here and I go all the way down to 30, right? Another option is if you hit graph, it might be a little easier. If you hit trace, I can go 30, hit enter. Oh, and maybe that won't work because I have to have the window in there. So if I hit second table, I'm going to scroll down to 30. And right away, 30 is at 23.3. Here we got 23.3, and now we have to scroll down to 50. Okay, and it's just a little easier than evaluating the function each time. And I'll show you another trick in a minute. And 50 would be at, what was that, 42.5? 47.5. And now for letter A, the average rate of change would be 15.9 minus 5 over 10 minus 0, and that would give you end up giving you 10.9 divided by 10, which is 1.09. And if you remember, this is in thousands, right? So if I take that 1.09 and I multiply that by 1,000, you would get it's $1,090 per desk. Okay, so that's what you have to remember. I'm going to do the same thing here for B, and then I'm going to do the same thing for C. So go ahead and do the first assignment and come back again. All right, thank you.